One of you asked about this question. I'm recording this fall 2016. The student asked, and I figured, well, in the future somebody might have the same question. So here's what really made me think. So I had never looked at this exercise before. So we were supposed to graph the composition of this function and on itself 3 or 4 times. So, and then notice that they were supposed to notice that they all intersect. All those graphs intersect at the 0.66. So I went out to Desmos and I set up a composite function. Actually, I think I went in 4 times, but that's okay. And notice these all these lines do intersect at 6,6. So I was thinking, well, I did notice that those were the same. So I was thinking, maybe the identity function has something to do with that. So, but I wasn't sure, so I played with it a little bit, and then of course I turned to Wikipedia, and lo and behold, they said a linear function will have at most one fixed point. A set of nested or composite linear function will have at most one fixed point, and they gave this graph of this I don't know, some kind of cubic function, and notice how those points intersect the identity function. So I was thinking maybe I am on the right track. So I came back here and I had Desmos graph the identity function, and then I got really fancy and set up some sliders, and I want to say, okay, so if I change the slope and the y-intercept, is that intersection point going to always be on the identity function? So I don't know if you can see how well you can see this. Let's make it, see, it looks to me like changing the slope, whoops, it's always on the identity function. Let's see if I can change B, if that does the same thing. I'm convinced that that point is always on, that fixed point's always on the identity function, which would make sense because X and Y are the same on the identity function. So then, of course, I ask myself, why? How do I know? How can I make a prediction? Because the later question asks us to make a quadratic function for when X equals -2 and X equals 3. So let's go take a look at why it works on a linear function. Let me come back here to Zoom and let's see, what do I want to do? I guess I want to stop this share and I want to share a whiteboard. Okay, so now, so what I was thinking, well, I've got some slope A and some y-intercept, and I want to know when is that graph equal to X. And then I said, well, if I solve this for X, so AX minus 1X equals -B. I brought the B over, and then I'm going to factor out an X. So A minus 1 equals -B. And so X should equal the y-intercept, the opposite of the y-intercept, divided by 1 minus the slope. So I was thinking, okay, so for any function, what if I have -2x minus 3? Let's make a prediction on where the fixed point's going to be. So my formula that I just created is change the sign of the y-intercept and divide it by 1 less than the slope. So -2 minus 1 is -3. So I'm predicting that my fixed point is going to be -1, 1, because X -1, -1. Sorry, that should be the fixed point. So what do I do when -2 and -2 and -3 is my slope? So let's come back here. Actually, I can share my desktop. I didn't need to do that, did I? Okay, so negative, what did I say? I said change this to -2. Whoops. -2. Let's make this work. And change this to -3. Somebody with steadier hands than me could probably jump right to it. And I'm seeing an intersection point of -1, -1. So that's my pattern. Now, what if I wanted to what if I wanted to come back to, let's see, how do I do, I guess I'll do this again, go back to my whiteboard. Okay, so then how can I do this? How can I come up with the X values? I know the X value, so then I just got to play around with what the A's and the B's would be. So I was thinking, what if I wanted X to be, -2? So then what I just have to do is come up with what's a B value and what's an A value that will give me -2. And so I mean, there's a lot of possibilities there. So that's how I'm thinking about it. So that's how I'm going to start approaching the quadratic version of this. I'm going to stop this video, let you think about what I just did, and then see if you can come up with a way to do it, and then watch my second part of this, and you'll be able to see how I figured it out.